First question. A ball is traveling with uniform translatory motion. This means that it is at rest. The path can be a straight line or circular and the ball travels with uniform. Then all parts of the ball have the same velocity and the velocity is constant. Or the center of ball moves with constant velocity and the ball spins about its center uniformly. So we need to know that when a ball moves in such a way that the linear distance covered by each particle of the body is same during the motion, then the motion is said to be translatory or translation motion. Translatory motion can be again of two types, which is curvilinear and rectilinear. Accordingly, as the path of every constituent particles are similarly curved or straight line paths, here it is important that the body does not change its orientation. Here we can also define it further in uniform or non-uniform translatory motion. So correct answer for this question is option C, that all the part of the balls have same velocity and the velocity is constant. So correct answer is option C. Moving towards the next question. A meter scale is moving with uniform velocity. This implies, so to solve this type of problem, we have to apply Newton's second law of motion. And Newton's second law of motion says that the rate of change of linear momentum of a body is directly proportional to the external force applied on the body. And this change takes place always in the direction of the force applied. And thus the correct answer for this question is option B, that is the force acting on the scale is 0 and the torque acting above the center of mass of the scale is also 0. So correct answer for this question is option B. Moving towards the next question. A cricket ball of mass 150 gram has an initial velocity u is equals to 3I plus 4j meter per second and a final velocity v is equals to minus 3I plus 4j meter per second. After being hit, the change in momentum, that is final minus initial momentum, is. So according to this problem, u and v is given. Mass of the ball is 150 gram, that is 0.15 kg. So change in momentum, that is delta p is equals to p of I bar minus p of j bar. That is, p of j bar minus p of I bar. It is mv bar minus mu bar. Okay, so if I take m common, I can simply write v bar minus u bar. So m given in the question is 0.15. U given in the question is minus 3I. Sorry, this is v. So 3I minus 4j. Or I can write as in the bracket itself minus 3I plus 4j minus of u, which is given, that is 3I plus 4j. Now this both is minus, so we have to calculate it together. That is 0.15 minus 3I minus 3I, that becomes minus 6I, and minus 4 and minus 4, that becomes minus 8. So minus 8j. Okay, now I have to multiply the 0.15 inside the bracket. So it is 0.15 into, okay, let's take minus common outside. So it is minus 0.15 into 6I cap plus 0.15 into 8j. Okay, and when we multiply it together, we get minus 0.9I plus 1.2j, and thus delta P is equals to minus 0.9I plus 1.2j. Now looking towards the option, we have the change in momentum as 0.9I plus 1.2J in option C, and thus the correct answer for this question is option C. Moving towards the next question. Conservation of momentum in a collision between particles can be understood from. So, according to this law for a system of particles, so it is done from the both Newton's second and the third law of motion. Okay. So the correct answer for this question is option D, that is both Newton's second and the third law of motion. Okay. Next, a body with mass 5 kg is acted upon by a force F is equals to minus 3I plus 4J Newton. If its initial velocity at t is equals to 0 is v is equals to 6I minus 12J meter per second, the time at which it will just have a velocity along the y-axis is. So here, according to this problem, mass given m is equals to 5 kg. Then force which is acting upon the block, that is given F is equals to minus 3I plus 4J Newton. Then initial velocity at t is equals to 0 is given 6I plus 12J meter per second. Now the retardation, that is A is equals to F bar upon M, which is equals to minus 3I upon 5 plus 4J upon 5 meter per second square. And the final velocity is along y-axis only. Its x component must be 0. We have to apply kinematic equation separately for x component. That is, Vx is equals to ux plus a of x t. Then we get, if we put over here as 0, is equals to 6I minus 3j upon 5t. So t is equals to 5 into 6 the whole upon 3, that is 10 seconds. So looking towards the option, we have 10 second in option B. So therefore the correct answer is option B.